All right, welcome to the fourth Kubernetes Australia meetup. Thank you so much for making it tonight. So apologies that one of our speakers and our Kubernetes runner is unwell today, but other than that, we're all set and ready with our two topics. So thank you for joining us tonight at Red Hat. So just before I begin, acknowledge the country. So Kubernetes Australia and globally respectively acknowledges the traditional lands of the Kulin Nation on which we meet today and pay respects to past, present and emerging elders. So a bit about myself, I'm just currently studying commerce and computer science. So I'm actually the main founder's daughter who couldn't make it tonight, Yong Kang, but I'm really pleased to be able to help volunteer and gather everyone together for multiple meetups, as I've done during the Singapore meetups virtually and now fortunately in person in Australia. So what we have today, a bit of an adjusted last minute schedule, but I'm just quickly go through the rest of these introduction slides. And for our two main topics tonight, we have first of all by Paul from Red Hat here, a talk on securely accessed cloud with STS and ROSA. And following that, we'll have a demo by Prasanna Bhat, GitOps. So Prasanna is one of our volunteers from the very start, and this is his second talk for the entire Kubernetes meetup. So we really gladly welcome more talks as well if anyone would be interested, anything to do with Kubernetes for the future. And to wrap up, we'll have a raffle, which is where we'll do some feedback and open mic time. If anyone has any expressions on any sort of job opportunities, events, or just like to introduce themselves, that would be wonderful. And if time permits, we'll have networking and Q&A, followed by some announcements by Red Hat on upcoming events. So if you don't already know, K8SUG is also on LinkedIn, and we have a page where we post about all the upcoming events and everything from Australia to Singapore to we actually just launched Kubernetes Canada's official event upcoming August. So you're more than welcome to join any of those virtually, or if you happen to be there in person. And that's QR code that leads to all of our pages and on Twitter. And a big thank you to all of our main sponsors. Of course, our generous sponsor, Red Hat, again and again, has allowed us to use their venue and sponsor us with the amazing food and drinks. And also via CNCF, CloudCasa, as you can see from the banner, Google Cloud, and JFrog for some of the swags at the end. Thank you again to Red Hat. And one thank you to all of our volunteers. Susan couldn't be with us tonight, but we have Prasanna and Harrison and also Tiago joining us for the very first time. So yeah. So as I mentioned, we are always on the lookout for additional volunteers, sponsors, and speakers. So if you're interested at all, there are links just to fill out via Google Forms. And again, these are just our topics for tonight. So to begin, we'll have Paul with the securing cloud on with STS and ROSA. And this is just our upcoming events, as I mentioned. So we successfully launched K8SUG Canada via Toronto as well, and they had their first meetup on August. If you'd like to tune in during the live stream, or we will upload a recording as well. And here in Australia, very soon we'll have another meetup, this time at Google, at the 15th. And in Singapore, there's one at their Google office on the 23rd. And we hope to plan more events at Red Hat here as well in the upcoming month. So that's for after the talks. And now I'll just hand over to Paul for our first topic. Thank you so much.
Thank you.
Thank you.
but it was really an application platform, which is kind of different about OpenShift to other flavors out there, although everyone's trying to be an application platform these days, like Rancher and whatnot. But OpenShift was OpenShift before Kubernetes, right? There was a version of OpenShift that wasn't Kubernetes, right? It was an application platform. And then a couple of years into OpenShift, Kubernetes came back out and they made the heart of OpenShift Kubernetes at that point. They weren't interested in the cloud, and they dominated the on-prem market. Even today, I think OpenShift has 50% of the on-prem market globally, right, in Kubernetes. So that was their space. So they were a bit late to the cloud to produce their version of the hyperscaler managed offering, right? The ROSA is the equivalent of EKS for OpenShift, right? It's a joint product produced with Amazon, between ROSA and Red Hat and Amazon, and they produced this Kubernetes distribution with the managed control plane, so the same concepts of EKS, where they have the separate control plane that's managed by the hyperscaler and Red Hat. You pay for your worker nodes, and then it had the things we love about the cloud, right? Horizontal scaling of the worker nodes, and STS, which I'm going to talk to you about tonight. You use EKS, do you use STS? Web identity? Yep. So you're going to find this super boring, but but everyone else, it could be interesting. So one of the things I personally love about AWS Cloud is STS. I think it's absolutely amazing. And in the old days, I don't know about you guys, you're probably all still doing this the same, but we used to hard code passwords everywhere, right? And it was just how you did things, right? Everyone had the Oracle database password, right? It was in documentation, it was terrible. So what I'm going to talk tonight about is STS, but it's also about secrets management. So there's two concepts that we'll be sort of discussing tonight. I'm not going to spend a huge amount of time. It's only going for about half an hour or 20 minutes. Let me just get rid of this. A second. Yes. So yeah, two concepts here: secrets management and SCS. SCS stands for, let's put it on screen, Security Token Service, right? I must admit, I don't fully understand Security Token Service, right? And that's the beauty of the cloud. I don't need to understand it, right? It is a short-lived token that exists in pods in Kubernetes clusters, right? The Kubernetes cluster is constantly validating itself against an IDP, and that IDP is refreshing its tokens. And when it has those refreshed tokens, it can then go and assume roles in the cloud with group claims based on its namespace and service account, right? That's primarily what it's doing. What that means is that you can say this pod, right, on this Kubernetes cluster, or this OpenShift ROSA cluster in our case, is allowed to go and talk to this secret in AWS Secrets Manager. Does everyone know what a Secrets Manager is? Yeah. It's like same as HashiVault, or there's lots of flavors, or every cloud's got one. HashiVault's the big one that's kind of multi-cloud. There are other ways of doing it, but they're cool tools. Like AWS Secrets Manager, you can store secrets in it, like credentials or JSON objects, even certificates. And it also has the ability to rotate things. You can kick off lambdas from Secrets Manager, right? You can create a secret in an AWS Secrets Manager, put some credentials in there for a database, for example, build a lambda, an automation lambda that can then go in, change the password in a database, update the secret, right? And we used to do that at the bank I worked at all the time, right? Instead of having these hard-coded passwords, I've now got a password that's potentially rotating every 6 days, or whatever my time is that I want to rotate it, right? Maybe I'm rotating it daily, right? So I'm rotating the password, I'm changing it in the database, and you're thinking, well, how does my application know that the password's changed. And that's where STS comes in, all right? And what we're going to talk today about is a specific operator that is available in the ROSA catalog. OpenShift has its own operator catalog, which is like a software catalog that you can install things from. It's super easy. You install the operator, and when you install the operator, it will instantiate an instance of it. So the operator, if you don't know, is like a state machine in Kubernetes. It's like a manager of the app. So if I'm installing the operator for Secrets Manager, I don't install Secret Manager, it's just the operator. But then I can instantiate instance of Secrets Manager that the operator will manage using custom resource definitions. Okay. Right, so let's actually do something. And how many people here are familiar with Terraform? Good, okay. So we're going to do this all in Terraform today. I have already terraformed my ROSA cluster. There is a new Terraform module that has just come out for ROSA. So I've already pre-done that today. And I've already installed the operator and Secrets Manager on the cluster, but we'll have a quick look at that now. So this is the OpenShift console of the ROSA cluster that I've built in the cloud. It takes about 30 minutes at the moment to build a ROSA cluster with Terraform. That should be about 10 minutes within the next 6 months because they're changing the architecture out. We're moving to this hosted control plane model where the control plane will float on its own Kubernetes cluster with other control planes. So we won't have to build all these servers to run the control plane on, which is going to shave off 20 minutes off building ROSA. So here we have the operator catalog. And in here, I've got the installed operators, and external secrets is one of them. To install it, I just searched on it in the in here, secrets, search manager, external secrets operator. It's not a Red Hat operator, right? This is a community operator. In this operator hub, we have Red Hat operators, we have vendor operators where they've collaborated with us, like the Splunk operator or the MuleSoft operator, some of the big vendors. And then there's also community operators that we approve, but it's a trusted software supply chain, right? So it's everything that comes through this operator catalog. We know where that code came from, so it's trusted. And in the future, it will be signed. It's not signed at the moment. So I've already installed this. Like I said, when you click on this, it shows you the operator, but then you have to instantiate an instance of that operator, right? And I've already done that as well. It's called external secrets, I've called it. So this is the actual application that the operator is managing, right? An instance of external secrets. So it's the brains that's going to be sitting on the cluster that knows how to go and get my secret out of the cloud and draw it down to the cluster, right? Which is that piece I was talking about that's missing there. So my secret in the cloud rotates, changes the database password, updates itself to say that it's got the new credentials. External secrets is the mechanism, along with STS, which will be the authentication model of how it's going to go and grab that secret, right, and pull it down to the cluster for my application to consume, right? So let's get busy. So inside, so this is a little diagram. Another thing I love about OpenShift is that, when I click on this in the operator catalog, like all the documentation's here, right? It's so nice and easy to use, right? I just installed this. This was literally 2 clicks to set this up on my OpenShift cluster. I've got the documentation here. I can launch that documentation, and then I can get into how do I configure, pulling this secret that I want to pull, right? And this is a good little diagram of what's going on here. I'm going to have my operator and my external secrets, which is this circle in the middle. It's going to sit in one namespace. I'm going to have an application namespace. This one's called namespace-foo. I'm going to run, that's where I'm going to be setting up my secret that I want to pull. And then up the top here is AWS, and that's where my secrets manager is located. Let's have a quick look at IAM roles. So just to show you that there's nothing there today, I am going to create a role that's going to start with external. There's no roles there right at the moment that I can consume. I'm going to Terraform a role in a second. And if we also go into, secrets manager, secrets manager, and go into secrets, there are no secrets there today. Okay, this is a brand new AWS account, and there's nothing in there. Okay, right. Looking at my repository. So here's my Terraform. So if you're familiar with Terraform, you've got a vars file, which is some of the var variables you need. Sorry about this. I don't know how to get rid of this zoom bar. How do I collapse
You
it?
can move the green one from the green.
Oh, can I? Where is it? Where is it? Oh, yes. Hide floating. There you go. Thank you, mate. Right. So what am I going to be creating? Right. I am creating an AWS secret. We talked about this before. This is the secret I'm going to create. So in Terraform, to create an AWS secret, you need this piece of YAML, this little object, sorry, here. That's the actual secret I'm going to create. I'm also going to randomly generate a password. You can do that with Terraform, which is nice. And then I assign the version with the password to the secret. Right, you need all three pieces of this to set this up. Right, this is my secret with its starting password. All right, so we're going to create that. Over here, I'm going to create the roles I need. So what this means now is in AWS, how many people are familiar with IAM in AWS? Yeah. And web identity roles? Web identity versions of IAM roles? Just you? No? You must be. STS?
I don't.
Oh, okay. Well, good. Now you're going to learn something. Okay, so there's a specific type of IAM role in AWS Cloud specific to STS, right? And it's called a web identity role. And it's a different type of role than just your standard IAM role. And it allows you to talk to it from other applications using these short-lived 10-minute tokens. Yeah, it's all the STS token access. And what it relies on is the thing called an OIDC endpoint. Okay, with my ROSA cluster, whoops, sorry. I've got that back again. I'm not sure how. Hide floating. Oh, it just keeps coming back when I click on it. Every time I hit click escape it. If I click on this following command, ROSA describe cluster, that's my cluster name, and I grep on OIDC. When you build these clusters out, when I terraformed this cluster, I terraformed the OIDC object and the endpoint that it will use for STS, right? And I can just do a describe on my ROSA cluster and I get that endpoint. And it's really important because I need to put it in the role when I terraform the role so that the role knows how to validate my token. If you think about it, the cluster has the OIDC endpoint. And when I talk to the role needs to know that same endpoint to check that my tokens are, valid. So I've already gone and scraped this. I've then added this to my vars file. So I've plonked it in here. These are just some other variables that I'm plugging into my Terraform. We've gone through the secret. A web identity role looks like this. This is the part that matters for a web identity. It's about stating that it's a federated role. It's about the OIDC, adding that OIDC that I was just talking about there. And here I'm saying, the group claim. When we talk about claims, we're saying, this is the namespace I'm going to be allowing to talk to this role. And this is the server's account that's allowed to talk to this role from within the Kubernetes cluster. The rest of this file is just other access bits that I need to be able to talk to Secrets Manager. This is a policy that says this role can access any secrets in Secrets Manager. Now, I would never have it this broad. I've only got it this broad just for this demo. Usually you would say, you would lock it down to the actual name of the secret that you wanted it to be talking to. Down here, you also need KMS access. Secrets Manager is encrypted, right? So everything inside there, you need to be able, your role needs the ability to encrypt and decrypt with the KMS key. All right, well, I'm just using the default KMS key today. So it's all the important things that I need to terraform these roles. So I've written a nice little make file to do a terraform plan. I think I've already initialized this. So I can just do a make plan. And whoops, hold on a second. And maybe I've already applied it. Thought I already blew it away. Oh, there you go. I didn't save it. So, so it's saying 8 to add, right? So if I look up here, scrolling up, you can see here, these are the resources. That's the password one at the bottom. There's the secret. These are all the policies and the policy attachments. There's my web identity role. So these are all the things that my Terraform is going to create when I run the apply. So I'm going to do that now and run the apply. And it's going to happily go and create these components for me. 8 added, 0 changed, 0 destroyed, which is good. So if I go now back into here, and I think I need to refresh. No, there it is, Foster Test 2. That's the name of my secret. If I go in here, I will be able to retrieve the secret value. And this is the value of that random Terraform that I put in there. Okay. And you can see here, edit rotation. That's what I was talking about earlier, right? This secret, I could add any kind of script or something in here that's triggered by Lambda that will go and rotate this password. But I don't have anything there today. So there's my role, my secret. If I go over to IAM roles and refresh this page and look for external now, we should see my role that I've created. And in here is the trust relationship. The trust relationship is what I was talking about with web identity. Here is my group claims. This is saying the server's account in OB dev test 2 namespace called Foster. So any pod that is using that server's account is going to be able to access this role if it's from a cluster with this OIDC. This is the OIDC here, right? So if it's coming from that a cluster with that OIDC as part of the token, with that group claim of that namespace and that server's account, you're going to have access to this role. And this role has a policy to decrypt and encrypt with KMS key and go and scrape secrets, any secret name. Okay. So next up, what I want to do is, I've done the Terraform bit, is do my actual demo. Now, the way that this bit works is I've built this little Helm chart. How many people use Helm? Good. Helm's awesome. So in this Helm chart are the things that I need to produce this demo. Okay, keep in mind, we already deployed the operator and the instance of external secrets. They're sitting in a namespace called external secrets or something. I can't remember where I put it. This is going to create my application namespace, and I'm taking that from my values file. I'm calling it OB dev test 2 is the value there. So that's the namespace I'm going to create as part of this Helm chart. I've also got this secret store. This secret store is quite unique. It's specific to external secrets. The secret store is telling external secrets in the other namespace what my server's account is. And the server's account, remember, holds the IAM role to tell the pod, you know, who it is, right? Which role are we going for, right? So it's a funny bit. I don't know how they coded this up. I've never looked at the code. Generally, when you're using STS, the pod that you're using STS is in the namespace where you're doing the STS. In this case, they've done some little wizardry where the pod actually sits in the external secrets namespace, but because of this CRD and this object here, this secret store, it can pretend, it can mask to AWS IAM that it's from that namespace. So when it actually sends the token, it's going to be from this namespace, OB dev test 2, not from the external secrets namespace where I installed the product. I don't know how they've done that, but it's nice. And it allows you to have one external secrets, but everyone in their namespace can have their own identity, right? And when you're talking about big banks and large organizations, one of the main reason we do this is because, you know, we've got these big shared clusters. You know, I want everyone to only be able to talk to their secrets. I don't want your team to be able to access your team's secrets, right? So this secret store allows me to say every team can have their own IAM role and access their own secrets by, you know, authenticating to who they are in that namespace. But I don't have to have a separate secrets manager in everyone's namespace. I've got a central one, if that makes sense. And that's what this secret store does. The next piece of YAML I want to talk about is the service account, right? And this is the magic right here. And funnily enough, for EKS fans, STS was made open source by AWS, right? It is an open source technology, and ROSA and OpenShift, we just use their technology. We don't try and change it, and we don't want to change it because, you know, we want them to develop it, and we don't have to want to keep grabbing it and changing it back to how we changed it, right? So funnily enough, on ROSA clusters, we have EKS annotations, which might look super weird because it's an OpenShift product and it's got an EKS in there, but it's just because it's open source technology, and we love all open source technology. What this annotation does is it points to the IAM role, and I'm getting that from the values file, but I don't have it here because I've just terraformed it. So I need to go in and sorry, it's just the screen's not long enough. Yeah, I need to copy the ARN of the IAM role. This is the role that I need to consume. Right? I'm going to paste it in here before I install this Helm chart on the cluster. When that Helm chart installs, it's going to substitute it into this role ARN as the annotation, right, for this namespace. So I'm going to have a service account. I've got the secret store telling external secrets to use this service account with this role ARN from the annotation. And then I've got the real glue, which is a piece of YAML called external secrets. It is the part that says, what's the name of the secret in AWS that I want to consume? What's the Kubernetes secret name that I want to make on the cluster with the values? How am I going to extract those values from the cloud, from that secret, right? So this is the data extract. This is how I want to extract it. This is the key. This is the actual name of the secret I'm going to create on Kubernetes with the data from the secrets manager secret. And like I said, this is the secret store ref earlier, which is, you know, how you get those group claims working centrally from the application namespace. So I'm just going to install this now. Install the Helm chart. Helm, uninstall Helm. Install. Oops, I'm in the wrong directory. I'm going to install that now. And so if I do an OC is the equivalent of kubectl in OpenShift. If you don't know that one, OC get namespaces, and I grep on tests. My namespace should be now there, 15 seconds. Yep. So it's created. So in OpenShift, you can do an OC project and the name of the namespace you want to go to, and it takes you in there. So now in this namespace, which has been created from this piece of YAML, I should have a servers account called Foster, because it's the name of it should be Foster. Oh, sorry, hold on. Is just going to be called service account name. Yep, so it should be called Foster. So OC get SA my Foster. That's it there, minus a YAML. So we can see that the EKS annotation on the service account is there with the correct role on, which is good. OC get secret store. Minus a YAML, I won't give the name because it'll give me it. So it's looks all good. It's just saying that that's the service account name that we're going to be using, right, to do my group claims against AWS when I contact AWS. I am then going to look at OC get external secret. So YAML, and inside here I am saying I'm going to create a secret called Foster-test2, and the secret store ref we already know about, and I'm extracting data from an AWS secret called Foster-test2. And if you remember in the cloud, we had a secret called Foster-test2. So it should have already synced. If I do an OC get secrets, here's my secret, which is created, which is great. And inside here, is my YAML. And if I grab the data, which is the echo hot to base 64 minus D, that's the value I've got in the secret. And if I go back into my secret, it should match. There it is there. So it's pulled that secret successfully. JS, blah, 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 XN, which is correct. So I've successfully consumed this secret in a very secure way. External secrets is getting the Kubernetes cluster is constantly proving who it is to the IDP. It's getting those short-lived tokens inside the external secret pod. That token is rotating every 10 minutes. Right? It's highly secured, right? If I want to go and consume that secret again, I think you can throttle it. It will be constantly polling that secret for new information. And one thing we used to do in the bank is we used another product called Reloader. Have you heard of that one? It's this rad little tool that you can do that watches your secrets. Right, so external secrets is constantly polling that secret, right? I've got a rotation lambda on the secret, which is once a day or once a year, rotating the secret, but before it rotates it, it goes and changes the database password with a new password, updates itself with a new password, right? My external secrets pulls that down to my Kubernetes cluster, changes the secret on my Kubernetes cluster. And because I've got a thing called Reloader, which basically is another annotation that you can add within the pod, right? And you say, watch this secret. If this secret ever changes, restart, right? And it does a rolling restart of my pods. So as soon as the database password changes, right? If my pod is talking to that database, it keeps its connection string, right? But just because the password changes in the database, it doesn't mean that my pod's connection dies, right? It's already connected to the database. But if there was a gap between the time the secret got pulled down and if my pod restarted, it wouldn't be able to connect. So it's only connected because it's got the wrong password the moment it rotates. But generally, you don't find that happens, right? Because you're only changing your password once in a blue moon, right? By the time my password rotates, my pod it hasn't restarted. The secrets manager's polling every 10 seconds or whatever, pulls the secret down, Reloader tells my pod the secret's changed. My pod restarts, it reconnects to the database with the correct password, right? So it sounds complicated, but it's something we did all the time in the bank because we finally had a mechanism to not use static passwords, right, in a highly secured way.
Are there any instances like rotation fails?
Yeah, I mean, your rotation can fail and it's logged. So it's certainly something you can monitor. So all the rotation logs appear in CloudWatch. So you can monitor for failures and things like that. Yeah.
What would be the next action if it rotation fails?
So it depends where it's gotten to. So, you know, if it went and if somehow it rotated the if it got the new password, rotated the password and then didn't update the secret, if it failed in that part, you'd be in big trouble. Yeah. But it should never do that, right? I mean, that's like a piece of code failing in between two lines, right? You know, but, I mean, I guess if there was a huge outage right at that split nanosecond, maybe something would happen.
So,
But
in that instances, maybe a vault could support good.
What? Sorry.
In that instance, like if it rotation fails, so in that places that the HashiCorp vault would be a good option.
Okay, that's a good point. Okay, so there's a whole array of solutions for Secret Manager, right? There's the cloud secrets that we're discussing today. There's also a thing called sealed secrets, which is a completely different mechanism. Sealed secrets are kind of cool as well. I like sealed secrets, although they're generally frowned upon by security people.
You can commit secrets into his Git repository.
Yeah.
You would like to have a sealed secret.
Yeah, sealed secrets are kind of cool, but you know, if you talk to security people, they hate them.
I kind of do not agree with it, but
Yeah.
why you would like it.
Yeah.
How is that? How to understand that sealed secret?
Basically, in the sealed secrets, you install sealed secrets on the cluster, and inside the cluster, it contains it contains a certificate to encrypt and decrypt certificates. That's decrypt strings, right? Encrypted strings. And what you can do is you can query it. You can take a password and you can run a binary that goes and queries it if you've got access and says, I'm going to create a secret in this namespace with this password. It will come back, give you the sealed encrypted string, and then you can go and put it in your Git repository. You don't care anymore. Because unless someone's got access to the cluster and can get that certificate, they can never decrypt it, right? So you can put it in your Git repository, and then you can deploy your code to the Kubernetes cluster. And it's a piece of YAML or CRD again called a sealed secret. When it hits the cluster, that same pod will decrypt that component and create the proper secret as you want it with the actual password in it. It's kind of cool, but yeah.
The reason it will help normally, the reason why it is something which is very helpful, because if you want to have a GitOps for your cluster, it allows you to push all your code inside a GitHub repository without having to worrying about the different secret manager components.
Yeah, it's simpler, but security people hate it. Security people don't agree with it.
So the challenge with that is it's because it's a static secret, right? In case of STS, we
correct.
Have to keep on
Great point. Yeah, you only use it when it's going to be static.
Exactly.
Right. If it's going to be rotating, you're stuffed, right?
Because
then you're going to have to keep going. Remember, I've got to remember rotate this all the time, right? So yeah, good point, right? So, but getting back to your point, HashiCorp Vault is better than all of them, right? HashiCorp Vault does not create Kubernetes secrets, and HashiCorp says that their main argument about it is that Kubernetes secrets aren't secure, right? Because they're not encrypted in certain ways within etcd database on the master nodes.
It's not secret. It's not
even a secret.
Yeah.
Man. You just decode it.
That's right. I think it's encrypted at rest. It's not encrypted in memory, right?
Base 64.
Yeah.
At very honest.
That's right. On the cluster, it's base 64. That's right.
64.
That's right.
So you can't say that.
So it's not. So their argument is not secret. It's not secure, which is a fair argument, right? It's just a config map at the end of the day, right?
It is a config map and just
it's bullshit, right?
Unless until you are encrypting your etcd, and then probably then you have to implement it. There's Kubernetes supports encryption.
OpenShift, you can encrypt your etcd.
etcd,
It adds a delay, right?
Yeah,
exactly. So that was my point. So you can encrypt it if you do that. But what HashiCorp does is when you do interface with HashiCorp, it never creates a secret. It mounts the secret directly into the pod, right? It makes it available as an environment variable within the pod that the pod already knows about it.
Yeah.
Right. And there's other CSI type secrets. There's another method called CSI where it's a stateful mount into the pod as well, right? Both of those, if you talk to security people, are the only way to do it, right? I've never done it that way personally, but we didn't have access to HashiVault with the last place I worked at. But yeah, I think HashiVault, it comes out number one, and the CSI driver
Right.
comes out equal to that.
Even in case of his query, the process that you have explained, which if it, let's assume the sync fails, and if it is a periodic, then probably the next time it tries to resync, it will be able to do that. Right?
Yeah,
So you just have, what will happen is any kind of resources that are created inside the cluster will just destroy it and get created and new resources with the new secret that have been updated.
yeah. I think the only problem is if it rotates the database password and then fails immediately after, right? If it did that, you'd be in trouble. But I mean, if you're rotating a secret once a year,
Is there
I mean,
is there a way to rotate the passwords automatically of the tools? Like, like let's say you deployed, I think in OpenShift you use the catalog, right?
Mhm.
But let's say you're using ETS or something, we use Helmchart.
Yep.
Right, and over there, there's username and password. Sometimes we hard code the username and password in Helmchart. It's deployed.
Mm.
The secrets are generated. The secret is generated by the Helmchart because
Yeah.
from the values.yaml file.
Yeah,
Fine,
yeah.
but is there a way that we could rotate the passwords of the internal secrets, not the? This is something.
There's nothing that really does that. There might be a product out there. I'm not aware of it.
Right, so now I got it. Like, so this STS is something where you manually or automatically have.
So keep in mind, STS and secrets managed are two different things,
Yeah.
right? We're using STS to retrieve this
Yes,
secret,
this is the retrieve.
but STS can be used for go and talk to a bucket or go and
Yeah.
talk to a SNS queue.
It's
You
kind
know-
of your identity of it, your resource identity inside the cloud. So once you have once your pod has identity outside the cloud.
Yeah.
You will be able to access all the
I
services
understand.
which are available.
The
in
only
the
thing
cloud.
what I'm trying to understand is like, it basically, like, what is it solving? Like, it's.
Well, so basically in the old days, and you still see this all the time, people still have
like,
passwords
they-
for the
they change
database.
Yeah, if they change the password, then they have to change it manually over here. Is
Totally.
that
Or they
correct?
change it in their Git repository, right? And they've hard coded it there. Where do you store it
Yeah.
in a CI/CD pipeline? There's no way of doing it unless you use sealed secrets, which are okay, but you can't rotate easily because every time with sealed secrets, every time I rotate it, I have to go and re-encrypt it with my hands. You could have a task, I guess, in the pipeline to go and re-encrypt it, but then how's the pipeline talking to the cluster, right? Then you're hard coding a password there, or maybe you've got passwords inside Git, right? In those, you know how you can do them in the variables in the secrets inside Git. Where I've worked, secrets inside Git are very frowned upon because there is no tracing and auditing of rotation of those passwords. So you know what I'm talking about in GitHub Actions,
Yeah.
you can create the secrets.
Yeah.
There's no tracing of that, right? So if someone goes and changes their password, you've got no idea someone's changed it. Which is
There is a time, like, duration that you can see that, like, when it was last updated or created.
oh, can you? Right. I've never
Like,
seen that. Okay.
That's just like a
Yeah,
basic thing that
yeah.
I experienced.
Gotcha.
Yeah.
There you go. But there's probably not logging of who
Oh,
who did
GitHub
it.
Actions, like when it comes to the CI/CD, it lacks a lot of things. Like you don't get to see CPU or resources.
Yeah,
battery. You don't get to see
Who did what, but it doesn't get that, and that's why it's a bit of an anti-pattern. The secrets within GitHub or GitLab, if you put them in the repository, it's a bit of an anti-pattern for Git itself, right? Because Git is all about knowing who did what, right? It's all about, I changed this and here's my merge request and this is what changed, right?
Yeah,
and this
it's
was
for
the
the source
user.
code.
But then you've got these secrets that, no one, they're not doing that for, right? So they're frowned upon. That's why, and that's why getting to GitOps, and I love GitOps. I talk about GitOps all the time. With GitOps, you can't, I've completely lost my train of thoughts. What was I just saying? The
GitOps and GitHub.
no, before that,
No, keep this-
oh, sorry. Point in time deployments to clusters, right? A pipeline should never talk to a cluster. The only time I ever do that is when I first build a cluster. When I first build a cluster, my pipeline will go and seed the cluster with maybe the first Argo CD application I need to plonk on it, right? After that, I don't let anyone talk to my cluster from a pipeline, right? So there's no way of having those passwords or access to the cluster. Everything's going to be managed by Argo CD, which will hold the credentials and manage that securely, right? So again, you've got to think about in the real world, what is the most secure way of doing these things? I think I'm done.
Yes.
One more, go.
Yeah, in case of, as you said, that the STS, in case of the identity, your identity to the OID endpoint kind of is referred from the operator, not from the pod itself,
Yes.
right? So I just want to understand so the STS token that is being referred in the OICD endpoint is the STS token of the pod, or it is the STS token that is present in the OID, operator workload.
It's from so in that namespace where I deployed the operator, there's the operator and there's 3 pods that come with secrets manager.
Okay.
So they're all in that namespace, right? So it's one of those pods. It's called secrets something.
Okay.
It's just one of them.
So basically, our pod which wants to collect a secret, that first have to it will if it requests a particular secret, then the request will go to the operator. Operator will
The operator does. The operator is really only about managing the application. It's not going to do the application's work.
Okay.
So the operator will upgrade the secrets manager when a new version comes out, or it will instantiate another version of secrets manager.
I just want to understand how the pod connect to the secret that is.
I know I don't understand. So that secret store thing, secret store is in the namespace. And it allows the secrets manager in the external secrets namespace to pretend that it's in this namespace. And I don't know how they do it.
Okay.
Yeah, it's something. It's cool, right? It's
token from the service account you provided.
It's using the token for the service account provided for the secret store, but the secret store is not a pod, right? It's just a CRD.
But in your Terraform, I saw that you actually specified that in the words is that this namespace.
Yes.
Yeah.
Yeah. So my role says you've got to be in this namespace and you've got to be this secret account.
So when when a pod wants to speak to let's say it is at the end of the day speaking to AWS API to that service. So that's where the communication actually has the IAM. Whenever you created the Terraform, it already included all those.
Correct.
The granular concept.
Details.
Oh yeah. But the thing is that how are you going to solve it for 100 namespace?
So that's why you have the central external secrets. So that's why you have that secret store, and that's what I was talking about. And it's what he was. What's your name again? Sorry,
Ashwin.
Ashwin was just talking about. So what's amazing there is that even though the pod is in external secrets, AWS thinks it's in this namespace, or it's respecting the group claims from this namespace, right?
Which is part of the operator itself, not the pod.
Which is part of the application namespace where I created those secrets. I don't have any pods in there.
Okay.
There's no pods in there. It's just a service account.
The operator talks to the Kubernetes API, collects with the CRD that you provide, you have a reference to the service account and the namespace you're looking for.
Yes.
This thing gets from the Kubernetes API, it gets the JWT token, pass it then back to this thing and get access to the secret and creates the secret within your namespace.
Yes.
So from the operator namespace to your namespace.
Yes.
If you don't like that, you can restrict everything.
But when the pod, which is not in this namespace, my role says only allow service account here in this namespace to talk to me.
Yeah.
But the pod talking to this is over here in this namespace.
But this one is privileged. And
Yes,
has access to the Kubernetes API. So
yes, but somehow I don't know how they do it. You're right. It's bypassing it.
Bypassing everything.
Yeah.
Access directly the Kubernetes API.
Yes.
Gets the JWT token for this user.
Yes. It's doing something like this. Yeah. It's like a hack of some sort. Yeah. A privileged hack. Yeah.
It's
a workaround. Yeah, it's a workaround.
But then when you deploy your XML manager, you can select if you want to listen on all the namespaces.
Correct.
Or just
There you go. You know exactly what we're talking about. Yeah, that's right. You can listen on all namespaces. That's right.
Or to answer your other question, you can create a cluster storage, which is then accessing for the entire cluster, having an IAM role, which is probably not that secure, but you can have access to everything.
Correct.
From
Yeah.
one secret, and then just from within your namespace, you just reference this cluster.
All right.
Yes.
Right.
Yes, I went for way longer than I was supposed to. Anyway, go.
Okay, so let's start with the GitOps. So how many of you know GitOps? Third, yes. Oh. So which is your popular tool for the GitOps?
Flux.
Flux. Wow. Flux. Oh, majority of Flux. That's cool. Oh.
Are you on the Zoom?
Yeah. No?
So you guys use Flux, do you? Really?
Oh.
I've never used Flux. I always use Argo CD.
I have not used Argo CD yet.
Oh yeah.
I used Argo CD in the past and didn't really like it.
Oh yeah.
And discovered the simplicity of Flux.
I heard Flux is not bad, yeah.
It's pretty good.
Mm.
Yeah, I haven't tested Argo CD since
Oh, yeah.
2019, so it's
Yeah, yeah.
evolved a lot.
These things do change a lot. Yeah.
I am. It's coming. It's there, yeah. So right. That's really cool. So Flux, yeah, Flux is one of another. It's also in the CNCF and Argo CD is the one. Another stuff which is also in the CNCD. But I love Argo CD for various reasons. First, my first attempt with the Argo CD and the same first attempt with the Flux, I succeeded with the Argo CD. I ran into a lot of trouble with the Flux, especially with AKS. And then I said, no, goodbye. But yeah, that's cool. Okay. So I got two repositories. One is the actual code repo, wherein I have some sample code, and another one is the Helm chart repo, wherein this deployment activity. So and also I got a Kubernetes cluster, which is set up locally with the micro K8S, which I will try to touch base at the end, which is super easy and fast to set up a local cluster on a bare metal server. Basically, it is running on my Mac, and it is just like 5 minutes. It's the Kubernetes cluster is ready, up and running. And then I have a Docker Hub account, which I use to push the repos, the container into the images to the Docker Hub. And I have also configured the Argo CD in my cluster, which eventually pulls any changes happens to the cluster. So step by step, we'll go with like we just start with the configuring the Argo CD to listen for the repository for the changes, and also we will demonstrate what happens when we make any changes to the code and we push the code to the code base. So there are two stages. So let me start with the first with the I'm going to change some code in my like it's just a Node.js app with some message like let's say the message could be something hello GitOps is that. So hello GitOps. So this change when I have configured this a pipeline in my Azure DevOps, and that Azure DevOps has the all the required tasks to push the changes that into the Docker Hub, which I am going to show this right away. So what really happens is like there is a Docker file. The Docker file has all the what it has to do, like how it has to build the container, and that is linked up in this Azure task, and this eventually pushes this code to the Docker Hub. And now I made the change And the change you could see here is it's building basically. And the CI/CD pipeline is building the Docker image, and it's pushing this code, and it's pushing the code with a tag which is build ID. Once we generate that tag, so that eventually appears here, that's in the Docker hub, and we just have to take this tag ID, and then we just use this into the Helm repo, which is which is consumed by the Argo CD, which we demonstrate next in the next stage. Yeah, so earlier, so we changed it to 328 now. This is the new tag ID after pushing the new changes. Yeah, so we got new tag. Right. Yeah, 329. So we just change this, and then we change this, push this code. Okay. Sorry. So let's go to the Argo CD side of the application. Let's configure the Argo CD here. Before that, let me talk about like so what happens in the Argo CD. Just I know like many of you know the what's really GitOps, but just giving a brief of what's the capability of Argo CD. Argo CD has the ability to pull the configurations from the plain Kubernetes like YAML file, or it's customize, yeah, all the Helm charts. These are the three different types of capabilities it has. And the configuring the Argo CD is plain and pretty simple with the series of commands. And it is just it's again a Helm chart, and using the Helm chart, and it just sets up that Argo CD. And biggest advantage of Argo CD being the mode of deployment for Kubernetes, it is about like security. Kubernetes clusters, as Paul mentioned in the just right before, that all those basically these DevOps should be used only to initially set up the cluster. It's not really to each time access the cluster every now and then, because it increases the surface area of attack. Means basically it is when a Kubernetes is accessed from the outside, we try to authenticate again and again and again, which is kind of a security issue. So, but advantage of the GitOps is like GitOps just sits inside the cluster, and it pulls the new changes as and when it happens. So that way it ensures that security is concerned, is addressed in the basically the area, the kind of like surface area of attack is reduced with that. That is one of the thing. And second is like I have seen different type of deployment models wherein the complex customer oriented environments, where suppose for example, one of a company I worked for, they have lots of clients, and if we have to automate the deployments through a simple DevOps thing, then we will have to have like so many countless number of pipelines in some kind of like Azure DevOps or maybe Jenkins, and each time we push this code, and then it has to make a call on like which of these changes has to go to which customer. That becomes too much complicated in these scenarios. But with the kind of these GitOps mechanisms, it can be like a pick and choose. It's really nice tool to have it. That's a kind of a brief I just want to touch there. So now let's configure this pipeline on the Argo CD. Okay. I would name it as like demo app, and project is default. So I have this repository already configured, which is really pointing to the one of the Git repository, which is in the Azure DevOps pipeline, which is this one for the Helm chart. I have previously established the authentications credentials, which is not really in the scope of this demo basically. So I'm just going to skip that portion. And that's the reason we got this repository here. And I'm pointing to this head branch, and the path is like wherever that repository is there. So basically it is able to gain access to this kind of folder structure, and then it is going to consume this value file. Then we are saying that it has to be deployed into this particular cluster. And because right now the Argo CD is sitting inside the cluster, so it is able to pick that cluster. We have to specify the namespace, and that namespace, I have already created that namespace. I'm just going to consume that namespace. Okay. So the value file is it's couple of configurations. It is different for it's almost similar to the Flux or the Argo CD or any kind of the GitOps tools we use. Just say create. So you could see. Oh, okay. Just a second. That was different. Let me check this. Demo and then default. This should be good. Wow. This.
What is the error?
It is saying invalid spec and unable to create the application, invalid spec. Maybe. Okay, let's do this other way around. Got this. Actually, demos are like this. Sometimes
demo gods.
yeah, yeah. But meanwhile, just bear with me. Let me create on fresh. It's a good thing for you guys also understand. Like it's a plain simple Helm create command, which is it generates one template for the deployment of any kind of an app, which in case you guys want to use how this Helm can be used to leverage the deployment. So I'm going to create something like demo.
He exists.
Okay. So yeah, demo folder is already existing. This is insecure. Okay. Let me see.
Everything under control?
Yeah, under control, just some kind of errand.
Errors?
Yeah, some kind of
Oh.
errand.
Demo gods.
Yeah, demo always.
Happens.
Okay, this is really not good. That's really not good. Okay.
That's the reason people don't like Argo CD.
Yeah, this is the first time like.
Doing our best to get back home.
Yeah,
Gonna
this
try our best to do it now.
actually it is yeah, it is not really.
That's not nothing to do with our, it's how.
Yeah,
What's wrong? What error are you getting?
no, actually,
just wants to create a, very simple, let's say,
Yeah.
one chart. Like
Yeah.
basic, you know how you do Helm
Yes,
create a
help create now.
apparently it doesn't.
Yeah. It
Oh,
is, it
it's
is,
not working on Mac OS.
It was working on.
it was working, but
Have you upgraded?
it is strange actually. Actually, sometime back it was working. So maybe,
This morning it was working.
yeah, it's more working. So,
It's not like because you've already got a file.
oh, actually it is created. It's something like it was only the warning. So let's push this code. Okay, that's still better. It created this code. Okay. So, let me push. Mm. Okay. Now, let's do this. Okay, we are going to fix this. It's almost there. So now we'll push this again. Okay. Let's go back to this gate. Sorry, the Helm chart section and try to pull this again. Demo app. Okay. Yeah, fingers crossed. This time it should at least not throw any.
Same.
Oh man, this is something strange.
It's like, is it your Argo CRD issue? Argo CD CRD issue?
It's
Or it's something like permission?
no, maybe permission.
Okay, just press create again, read the error.
Yeah. Refresh the apps. Refresh that. Okay, no app is selected.
Read the error, copy paste that somewhere else so that we can read the problem.
Yeah, okay. Next, I'm going to do this next. Bench is head. I'm just wondering like whether it is pointing to the. Just let me check the repository.
Is your repo?
Yeah.
Is it even connected to the Kubernetes stuff? Because you're not even talking
to the,
You're talking to the UI, right? Through the UI.
yes, yeah. But that
Yeah.
UI already means that the Argo CD is inside the
Oh,
cluster.
yeah, man.
Fully understand what it's running. I can see that.
Yeah. So let's see if it is the right one. Yeah, this is the right one. Yeah. Okay. This is the right one. Let's check this one last time. Then we just have to make a decision. Okay, let's just check this one last time. Internet is connected. Okay, I'm just checking the YamL. Let's see this if this works. It is strange. Okay. I think that's- Format document. Not readable. It's a strange error.
Go to the thing. Just
Unable
go-
to create the application. The application invalid.
Invalid releasing must match with it.
Behind you. It's just on the wall on the left side.
Yep.
The
So.
Go back in there. See on the wall there? Behind you. Behind you.
You should
Go
add.
there. Just on the wall on the right hand side of the wall.
oh, wait, hold on. Okay, did I add the caps there? Yeah, I think I created with the DDD capital, right?
So when you walk into the main room, on the left hand side, directly in front of you.
Argos, okay, create the app again. It's like, that page where you were
Yeah.
creating the app.
Oh
Yeah.
my God.
Sorry, the CD pipeline.
Yeah, here,
Yeah.
yeah.
Yeah, do that again. So
Do
do
not
not use,
mention it.
do
Yeah.
not use caps.
Hello app. Yeah, that's great. Hey. Wow, that's cool.
That's it.
Never occurred to me actually. Yeah, that's strange. Yeah, that's really cool.
Troubleshooting in K8.
Yeah, I mean, like it is.
Fun.
It's fun. Like,
And good, now everyone knows how to double.
yeah, troubleshooting on the go.
It's different kind of fun.
So now, yeah. So I didn't made it manual. I made manual, so it didn't happen. But if I had to
Hopefully, yeah.
think it now. Okay, now the link is failing this time also. Is it connected to the internet?
Yeah, can you stay a moment? Can you stay on, no,
Check your Azure login as well.
Yeah, one second. That is missing. Enable the hypersync, that's okay. So this time,
Hey,
okay,
behind me.
the namespace is there. One error. Let's see what is the error.
Have we got more errors?
Yeah, actually, yeah. Maybe, yeah.
What's going on?
So it is
It's not
something.
thinking.
Yeah, it is not syncing.
What's the error we're getting?
So it is saying it's
Accounted has. the
Yeah.
capitalized A inside.
yeah.
Needs to be lowercase everywhere.
Yeah. So maybe let's create one app with everything lowercase. That's could be I created that service account. Means basically I created the app with an uppercase somewhere here. Yeah, this one. Hello capital app. It didn't like it. Yeah. I need to. It shouldn't matter. You say.
I don't remember putting capital letters anywhere in mine.
Yeah, actually.
What is it? This is the name of what? It's the name of a.
A capital A.
But
Of
however it is, like, it's fine.
Let's do this. I will just delete
I
it.
don't remember, like, are you talking about this Argo CD or are you talking about the in Kubernetes?
What's the actual error? Show me the error.
It says
So which one are you talking?
it is not liking that
No, click
capital.
on the error.
Yeah. Maybe I'll remove the capital A and I will just recreate it. Because domain, it makes sense because DNS it can't resolve. It's a case sensitive in Linux.
Yeah.
It does make sense. Yeah. Yeah.
It's a good thing. You learn something new today.
Yeah. Yes. Oh. Let's do that again, okay? And it's a good thing, okay?
Everyone is going to remember.
Yeah, this is something very crazy. It's a crazy thing. Yeah. Let's do this. It's got in control. Just 2 minutes, bear with me, and then we'll be there. Okay, this is the demo Argo. I just name it simply. And then we go to this folder. DDD. Reveal in Explorer. This time it shouldn't be an issue because all the caps, everything is taken care. I never knew this so far that caps is a problem because I never used even caps either. Yeah.
But in case you don't use it in the future, caps just put a hyphen in this.
Yeah. 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 True. That's good. Now we just push this code and let's get going. Okay. So what is the gut feel now? Guys, it's deploying. It's doing the job now. Finally.
Everything is as it should be.
Yeah, everything as it should be. Now it's basically it's winding up the older stuffs and it's syncing it. Yeah. Actually, I didn't knew the caps. Caps is a great learn. I have created. Yeah. Actually, I have created lots of. There is a one repository. Means I created all this repository under CSCD. They're all like small. There are around 70 microservices are there.
Lucky that you chose it today.
Yeah, I'm not lucky today actually. 70 repositories all.
Demo. It's a demo.
Demo, yeah. So finally, that's so this is how the whole Argo CD how it operates when a code is pushed to the code base and the CM container is built and then the sync process takes place. So once we update the tag and let this sync. So if it is configured to be like auto sync, every time we push this code, it deploys it. That's about the Argo CD's capabilities. And any questions so far? Like, and after that, I'm going to touch the micro K8S a little bit. I'm going to talk about like how do we spin up the micro K8S.
How are you managing secrets with that CD?
Yeah. So again, this is a kind of like, it depends. We could like, if it is in the cloud, then
You can use KMS or something like that.
okay, without cloud, when it is integrated with the cloud, yeah.
I was just checking for this particular application.
I get it. So if we have like, if we are not going with any cloud-based solutions, then if we are going to have our own like HashiCorp thing and all, then we could use it deployed in the cluster, something like that. Otherwise, if it's a cloud-based solution, we can always integrate with the, if it is Azure, we can use with the Azure Key Vault. If it is an, yeah, exactly. And IDAM integration we can do. Active Directory integrations, all kind of managed identity policies, everything. The one Paul mentioned about like because in EKS. So in Amazon, same way in Azure, there is an IDAM and Active Directory and
Only two issues normally I face with this kind of integration, or rather GitOps, is that the first is the secrets management, and the second is what kind of privileges does the GitOps manager itself requires, like in case of Argo CD, what kind of capabilities or permissions are present for Argo CD inside the cluster, as well as on the premises from where it will be pulling the basically pulling the source code itself. Like
Yes. So Argo CD is only just snatches that responsibility of deployment from the DevOps into this site, and then rest everything like secret management, like again it goes again like pull based mechanisms. Like it doesn't really addresses the secret management. We just have to have like either there are many different tech example, like if we always can pull the secrets from the, if it is outside the cluster, we can pull it from securely from somewhere like other class secret management providers, or if it is inside, then we will have to have that kind of our own vault mechanisms, which has to be set up once before, and then could be reused again and again. That's pretty much of it. It doesn't matter whatever we deploy, it just deploys. Like it could be any services, or it could be
interested in micro-K8S. Actually, I have used K3DS, but I have not used micro-K8S yet.
Yeah. Okay. Let's we can talk about micro-K8S basically. See, it is synced now. Everything is it's synced up. So
I think like so you are saying like it will be already in cluster, right? So before that, how do you ensure that cluster is also is there any way like?
I'm sorry,
you're saying that this Argo CD will be in cluster already. So before deploying into it, is there any mechanism to check that cluster is fine and everything? Or
okay,
only if it is cluster is good, that only will deployment happens.
Okay. Yes, we what I used to do in the past is like as part of the Terraform deployment, I used to create the cluster.
Okay.
And then I used to deploy as first initial in the beginning setup, I used to deploy all the Argo CD, like one-time activities. I'll ensure that everything is in place.
Okay.
And then after that, also I configure, example, Argo CD provides the ability to export the configurations, and it comes as another deployment Helm chart file.
Okay. I mean,
this Helm chart itself can be automated in our CI/CD pipeline, so that we do not have to really come to the UI. We just go and configure it, everything.
I just was looking like, is there any health check before running CD about the cluster?
It is we could put like kind of like use some kind of tools in our pipelines to see if there is if the cluster is all good and functionally working and everything. We could use it, but yeah, it is it is usually if it is good, cluster is healthy and good, then like example, network is DNS, all the required add-ons are there, or like a DNS is set up, CNI, all those things are good. Straight away, like it should be able to, and then rest of everything like scalability, scaling, all those things are again, it's a different thing.
That's fine.
Yeah.
That's
yes.
My just concern is like if it is cluster is bad, something bad, it's not healthy.
Yeah.
So still this deployment will happen, or what kind of thing we can get to know. I'm just curious.
Yeah. Because
What are you guys talking about?
yeah. So he's talking about like clusters, whether it's in a good state or not, like kind of thing. How do we get to know whether it's in a good state?
The cluster?
Yeah,
Well,
before deployment.
Well, it depends what kind.
I
you got,
just want to like
Yeah.
ensure that the cluster is healthy.
Prometheus, you mean, like that sort of thing, like monitoring.
Okay.
But yeah, generally you use Prometheus, so I mean, Prometheus is fantastic, you know, and it's
Yeah,
free,
we can,
free, which is amazing. It's as good as any of those other stupid monitoring tools that they say they cost a fortune.
Yeah.
You know, there's no metrics that Prometheus can't get that anyone else is getting. It doesn't do application performance monitoring, it doesn't do your performance stuff. But from a Kubernetes perspective, it's fine.
Yeah, it's fine. Yeah, we can integrate with the Prasanna, so we can even
Yeah.
have a good.
That's right, and alert manager's great, it's got lots of interfaces and very good.
So I'll just
And you
quickly,
can GitOps everything. You can GitOps all the Prometheus stuff, which I love. Same with my pipelines. I use GitOps for everything. I treat everything like an application. Whether it's Prometheus, whether it's my pipeline, I just wrap everything in Helm charts. Or the GitOps.
okay, so let's, I'm just going to quickly run into this micro K8S way of spinning the cluster. It is pretty straight and simple. I think most of I love exploring lots of distributions. Back then, I wanted to go with the what distribution I should use. I tried with many ranch, micro K8S, K3S, everything. Yeah, lots of countless, and even a bare metal as well, like just a plain Kubernetes way of doing the things without any kind of distributions. But this one is the one stuck in my thing because it's super fast. But yeah, it's again, it's depends on like where production, everything, it is entirely different how secure we want it to be. But for the local development activities, everything, we just simply straight away just series of these commands. This just straight away spins up a micro K8 cluster. So since I have already installed micro K8S binary, if I just say this command, and this is going to spin me up the Kubernetes cluster, and with no extra effort.
So would appreciate if you could from the basic. I'm really interested in microKs.
Yeah.
So it's a kind of basic thing you're just stating, right?
Yes. Yeah. It's sorry. Okay. So yeah, it's okay. Let's go this way. If I have to say micro K8S, then let's say micro K8S install, like it could be like, let's say Mac. So it straight away gets started. So here we do not have to, we just have to choose which operating system we are on. And example, it could be a Mac, or it could be an Ubuntu, or it could be some other things. All we have to just make sure that we are right on that kind of OS we wanted to install. That's once that step is over, we just go to the go-to guides and then go to the installing things and then choose which one we want to start with. In this case, I'm going to start, say, Mac OS because I'm on Mac, and then straight away it brings it me here. And this is just executing these commands, nothing, no extra effort. And this is it. And once this step is passed, the third command is, this cluster is ready. After this, you just enable any add-ons you want, like dashboard, DNS, registry, and this is the service mesh, Istio, east-west traffic. Then, that's it. And then you can straight away start using it, start deploying your applications. It's a pretty much faster way of doing the things.
I'm a big fan of Kind.
Which one?
Kind.
Kind is another one. It's really cool.
I'm a big fan of Kind because it gives me a full-fledged cluster rather than having. In case of K3DS, the problem was that it has it has limited number of controllers present in it.
Yeah.
Whereas Kind has full-fledged Kubernetes cluster, as well as it allows you to add multiple nodes into the cluster.
Yeah.
Rather than in case of what you can call Minikube, you only had one node.
Yeah.
That's the reason I like to use Kind to develop anything that I want to.
Yes, Kind is quite very much close to the actual implementation of the Kubernetes. Yeah, it's really cool. This is about the any questions?
Is it called Kind?
Yes,
KIND.
yes.
Yeah.
So
So generally, Minikube requires a hypervisor and all, right? So with micro K8s, it's much faster way of implementing
In case of-
Kubernetes locally, is it?
I don't know about micro-K8s, but in case of kind, you will require. a
You can
Docker
use
container.
micro for everywhere,
So
Okay.
even production.
basically what it does is it creates multiple
yeah.
Docker containers
I mean, like,
and emulates the
Uh,
virtual machine itself and then actually deploys containers.
I mean, like,
inside those.
you can use
Docker containers.
canonical basically.
It's kind of an inception
Okay,
that
sorry?
happens over there.
Like I'm asking, like under the hood, when.
Probably lightweight than as compared to Minikube, I guess.
Like QVM or.
Minikube requires a lot of resources.
You know,
as well.
I
Yeah,
can
yeah.
tell you,
All-
it's Core OS underneath the Linux
Yeah.
So
distribution.
your control plane
So you know what-
and
do you know
your
what Core OS
application
is?
is also on the same.
So
node.
it's like a
Whereas in case
container
of
platform
Pi, you
itself.
can use, but you
that
can
there's
have
an
multiple
ignition.
nodes that
AIM.
that are irrelevant
AIM
of the control
within,
plane node. So you can have a
AWS,
feel of applications
and it
which are,
connects to an ECR.
which how will they be
or a
deployed inside?
Container
a
registry to
cluster
download
rather
the
than
rest of the
one
images
that
for the
you
actual
have.
nodes themselves, for the master nodes.
And it
Because
has
I
to
did
be
run
already
into
installed.
memory issue.
I
I'm sorry?
don't know.
I did run
I
into
don't actually know
I
that
use
part. how
32
it actually
GB,
works.
32 GB RAM
Yeah, I
and
don't know, 'cause
16,
yeah, so Core
sorry,
OS
30,
downloads like
16 GB
pieces
RAM
that
and
make it Core
around
OS, 'cause the
50
actual
to 100
AMI, which is
GB of hard disk
just
to
the
run
ignition.
my virtual machine, in which I run my kind.
Yeah. okay.
pulls it
So
all
it requires
down,
a lot of.
builds the nodes,
Yeah.
and then,
And honestly, if you are running
and then,
Kubernetes,
yeah, it must.
it will
do
require
stuff for it's just raw
lot of
Kubernetes at the end of the
When
day.
yes, this is when I try to eliminate all this, like
Yeah.
V3, kind, Minikube, whatever you say.
Yeah.
When you're doing something to do with production level and like a higher scale level, like.
That's
what is
right.
that? I wouldn't recommend anyone to like really touch them.
Yeah.
Because they work a bit differently. Yeah, if you want to play around with it and learn.
Yeah.
It's an excellent way to. do
Yes,
it.
yes, yes.
You can do it in these kind of environments, but when you're doing it in the production environment. Like imagine.
Yeah. Yeah.
You started a cloud company and you want to give Kubernetes as a service, right?
Yes.
You wouldn't want to choose any of these software. You
Yeah.
gotta
Yeah.
do the hardware.
Yeah.
So that's the reason.
That's right. Raw
Yeah,
Ku-
so
raw
you gotta
Kubernetes.
like separate
Yes.
these two breeds.
Yeah,
I'll say
exactly.
that.
So I was in a customer today and they were a big customer. They're a big enterprise, their organization, and they are building their own Kubernetes stack.
cool.
What are they called?
TCK or something they're calling it.
In
But
Australia?
Yeah, big Australian company, and they're gonna do it with just the standard proper. What's it called? AMD? I can't remember. How do you install old school Kubernetes?
QADM.
Kubernetes.
Kubedium.
Can't even remember.
Oh, they're trying to do it.
You know, I did get my.
I know.
I got my CNCF certification, but it was about 7 years ago now. But I did use to do
I know,
that
I know,
Cube
but
ADM.
There's
Cube
two
ADM.
ways, right? Now you
Yeah.
do QADM or you do it the hard way. There's something called.
That's right.
the-
Kubernetes the hard way.
Yeah.
Yeah.
that
What's
was
his
the-
name?
you
The
know,
guy who wrote the book. I can't
No,
remember.
so it requires
What-
all the components to combine.
Maybe. Kubernetes the hard way. That's
that
right.
was
And
like-
you actually build it all yourself. Yeah.
Exactly.
Or you install all the code.
certificates. You install the certificates for
That's
SPA,
right.
HCD.
By the end, you're a master. You know.
Yeah.
Yeah.
And actually, like,
It's a good thing to do.
whenever someone asks me like, how did you learn it? I recommend them like do
Yeah,
this,
yeah.
so that you actually know the core stuff.
Yeah.
Because right now, the way I saw the exam pattern that people are missing out.
Lot.
That's right.
Yeah.
You learn heaps of shit.
Yeah, you learn, but people are missing out now.
Yeah.
Like right now, because the job market is like, you just want someone. And as long as you know how to play around with the commands, the
Yeah,
admin level.
that's
they're
right.
Happy with that. I'm like, nah, there's way more to it.
That's right. It's so true.
It's way
It's
more.
so true. Yeah, look, I mean,
Oh,
learning, the best way to learn is to fail, right? It's like, I remember when I first got into Kubernetes, we were trying to build some Tivoli stuff with IBM stuff. And oh man, we just could not get it to work because we just didn't understand what we were doing, you know? And it just took us days and days of trying to figure it out. Well, at the end, I was pretty good at Kubernetes. You know? I tried everything, you know?
I'm
So-
not sure how many of you have tried actually integrating Prometheus with your workflow.
Prometheus, make no mistake. Prometheus and monitoring are the most difficult things.
Exactly.
It's a whole different.
It's a
There's
different
nothing-
kind of fun altogether.
It's
Science.
another Kubernetes at the end of the day.
Oh, yeah.
Yeah, it's.
Prometheus is like science and maths. You know, you gotta be like, you gotta do like quantum stuff and like what the fuck, you know?
And then you realize that you have to add a label to your workloads. And
Oh,
you're
no,
like,
trust me, if you guys actually know how to use that, if like you can.
Prometheus
make one
is
of the best
amazing.
clusters. Yeah. you
Yeah,
can make one
it's
of the best
amazing.
clusters ever.
Yeah,
There's nothing
So
Prometheus,
difficult.
Prometheus can do everything that all these other monitoring tools can do. It's just harder. 'cause you have
it's
to
just
do it
harder
yourself.
to actually do.
Yeah, 'cause you have to like
Yeah.
figure out
So
the, you know, the vectrum spread or something.
Yeah,
Like,
yeah.
oh
And
my
then you
God.
need to even, you need to even code it in such a way that it needs to have the performance level code, like in the sense,
Exactly.
you can't have like
The cloud which is available.
random stuff over there, because you need to understand how it's going and going to read those data points. Because if you do it in such a way that it consumes so much memory and then your cluster will.
Like, it's a beast. I've had Prometheus that like doing like 20 gig of RAM, you know what I mean? Like,
Nah, I don't think.
It depends on what you,
Yeah,
how,
it's
what's the
not-
workload that you
That's
want.
what
You gotta do it very smart with it.
Yeah.
It's
The amount of data that you're pushing into
Yeah.
the Kubernetes, you have to think
Yeah,
about
but
that.
it's one of the best, like.
it's amazing
It's
tool.
a must,
It's
it's a
amazing.
must.
And again, that was one of the first things I worked with on Kubernetes.
But it's not that big, it's a requirement, that's what it is, at the end of the day.
Yeah.
It's a requirement.
Yeah, like.
All these companies, like Mercedes, manufacturing companies, they don't even have Kubernetes. Like, they still have Grafana.
Yeah,
Yeah.
it's the visual.
Yeah, it's evolved a
Yeah,
bit.
and yes, at the end of the day, what it is like, Kubernetes is like a skeleton, it has nothing, and then you have this meat on top of it, like Grafana and the tools. That's where the other niche skills come.
That's right.
Yeah, that's what it is. Yeah.
That's right, yeah. I mean, these days Kubernetes is so robust. What do you really need to know about it?
You don't really need to know, that's what I'm saying, you're gonna miss out all this, the hardware of Kubernetes.
So true.
Certificate management is already a problem
Well,
that,
that's,
you know.
learning certs is a big important part,
Exactly.
right? And
it's-
I didn't really understand, in 20 years, I didn't really understand. By the time I started using Kubernetes, I've been in the workforce for 16 years, I think. I still didn't really get certs. But then once I started using Kubernetes, I had to.
Yeah, you had to, like, you have to understand the
So then I
multiple
learned certs.
future certificate
Yeah,
authentication.
I'm
Usually you don't see that.
amazing at MTLS now, right? I know STO inside out, right?
You don't see that ever in your web.
No,
Normally,
the rest of my career, I was
STLS.
just sitting there just like, just knowing nothing, you know? Yeah, I know, we do a lot of work, I've done a lot of work with STO.
Let's say the same course.
And that's how I was forced to learn MTLS. But it's all on the wiki page. That's what I tell people. You're like, people are like, I don't know certificates. You're like, well, just read the wiki page. Like, there's an amazing wiki page on certificates. It explains the entire thing, right?
Because normally we, as a user of web, we know what is TLS, but it's just a single side, like server-side TLS
That's
that we
right.
know about.
Yeah.
But you do not understand how the TLS could be used for authentication, right? And yeah,
That's
exactly.
right. And also, people get it all around backwards. They think that the TLS connection is about protecting the server. It's not. It's about protecting the client. You know, what I mean, it's the first time you think about it, you're like, oh my God, it's about protecting me? What do you mean? Like,
These certs are, I found out like, so you know how there's Netflix?
yeah.
What it does is automatically.
Generates the-
generates them. It's a
Yeah.
beautiful thing, it does
Beautiful.
it automatically.
Yeah.
However, so there are some customers like the traditional ones who just got into Kubernetes, they would, like our security team is not allowed that simple. And then my question is like, why? But then I never got the answer for like exactly why would they not go for let's say because at the end of the day the foundation or the like the theory part it's still the same. The Let's Encrypt is just doing it in a it's just like it's doing it manually like
The same ciphers. The ciphers is the same.
yeah,
It's the same
it's the
encryption.
same thing. But so that's where like I felt like there's a huge gap of knowledge in the market where people are not aware of how these things work. Yes.
Yes. When it comes to the code rate, people don't like open source. When you are talking fact check.
Then had it looked government so now please explain what is the corporate
What data? What is?
I have a perspective around this. So basically, the reason why organizations would opt out because of the certificate transparency law, which are publicly accessible.
Is it happening?
And this allows,
Is it happening here?
This DevOps.
Guys, I just want to bring your attention to this thing on screen at the moment.
Yep.
So there's this modern application development roadshow happening with Red Hat. It's happening next Tuesday, 11 a.m. to 3 p.m. You can still register for it if you're interested. I don't know, most of you probably still got jobs.
Is it online?
You all got jobs or?
So there's.
You don't have a job.
I do
There's-
have.
I bet you have a job.
There's two tracks,
Um,
one that's actually in the office on the left is the developer
Yeah.
track. And then behind the little, just look at the screen on the right, there's application that's a virtual track. This is next Tuesday, the 25th. And then one more slide. This is what is that, August 1st? Another one, this is the security track.
Are you still in a
So
Zoom?
this is something we're
chat?
running for free.
Say
You just have
Are
to
you still in
register.
a
So
Zoom?
if you share this
You want to
slide
share
deck,
that?
or we could provide the link.
Sorry.
If you're interested, let us
Yeah.
know and we can send that link out.
Oh,
Share your
But once
screen.
again, this is something
What
we've
is
already
that?
run it in
Oh, yeah.
Sydney
Just
and in
the
Melbourne,
green.
and this is just continuing, and it's been so popular, we're probably gonna continue it a fair bit more.
Awesome. And then just
So
the
if you're
slides, yeah.
I'm
So
interested in the security.
I try and publish this by tomorrow.
Yeah, I'll send you these. I'll download this as a PDF and I'll send it to you.
It's just, it's
Perfect.
about microservices, DevOps, it's modern applications. The idea is, there's a lot of people out there still moving monoliths, right? Same old, same stack. And so this is us just trying to say, look, this is a new world. By the way, you can buy our stuff too, but it's really more about everybody kind of lift your game.
Because of the timing.
Yes.
So I'm like, who are you? Who's the target people?
So, yeah, it's enterprise organizations that can afford to send their people to this, right?
All right.
You know what I mean? Who do you work for?
I work for, there's a company called Foundry Digital.
Okay,
So, yeah.
so they want you there. They want you there on Tuesday. You have to turn up.
Living home.
Oh, you work from home a lot? Yeah, so do I.
Okay, yeah, that was just it, just so we're running these events, they're free. We
I
like
would
events.
would also mention there's another event next, on August 2nd here.
Yep.
If you just probably Google it, you'll find it. It's a different, not Yongpeng's.
No, it's actually
Meetup,
an
it's
OpenShift meetup. So today is a Kubernetes meetup.
Yeah.
Then one on August 2nd is OpenShift,
Specifically about that.
but that's run by another fellow named Ben Farr, who's a Red Hatter. One of Paul Spears.
So it's gonna be some cool stuff that night, actually. We're
And
gonna
that's-
go
yeah,
through,
pizza and beer, same thing.
we're gonna go through Backstage. Have everyone heard of Backstage? Yeah, so we're doing a Backstage demo. Red Hat's trying to build out their own version of Backstage, of like an API application portal where you can like come in and spin off all your environments. Right, it's pretty cool. Spotify invented it, donated to CNCF. There's gonna be a Backstage demo, and then I think some other is it Ansible or is it just OpenShift?
Our Ansible always.
Yeah, there'll be some Ansible stuff, which is like automation platform, if anyone's interested. If you just Google it, it'll probably come up, I think.
Have you guys started using the Lightspeed?
Not yet. There's a couple of, I work closely with the specialist architects for Ansible. And they've started playing with it.
Oh, that's the AI
Yeah.
part, yeah,
ChatGPT for
yeah,
GitHub,
yeah,
Copilot.
Copilot.
that's right, yeah. That sounds pretty cool, actually.
Yeah, we had a different name. Wow, and they actually codified it and made it like.
Was it called
Wisdom.
Wisdom?
Yeah, it was Project Wisdom.
Yeah.
And then they decided that's stupid, so they changed.
I was introduced to Wisdom in December, first week.
Mm.
And 2 weeks before that, ChatGPT came up.
Mm.
And I started comparing it, and I was like, I think ChatGPT is better.
It's funny, ChatGPT will get you 85%.
To be honest,
So
like
easy.
what matters to me is that because there's a lot of documentation.
Mm.
Because there's a lot of models, to be honest, I don't.
Yeah.
The thing is that from a user perspective, I felt like ChatGPT actually explaining all the points, however, it
Thanks for that.
didn't point me to the documentation. I
Yeah,
think
we'll
that's
just
what
do a quick wrap
uh,
up the feedback.
Right,
and-
so it does.
Yeah, thanks for sharing.
And the thing is that
Yes,
it actually gives you like a
thank
head
you.
start on how to get the data down. So
That's the whole thing. It's meant to be leapfrogging there. So if you get a playbook, it's 85% around, and you still need to read it. You can't just. But at the same time, if you don't have to do 85% of the work, I like that number. That sounds good.
But then it's sometimes
I felt like there's some stuff that I do in Ansible is that I can't rely on ChatGPT or even Wisdom or Lightspeed as well in the future, because the way to work around it is something that I know that the models can't do that. So that's a reason.
Well,
But
also-
it's a pretty cool thing, like
Definitely,
yeah.
but also it's just started. Imagine how it's gonna evolve in 6 months, 18 months.
I don't know, yeah.
It's gonna be, honestly, Skynet is coming. Get ready.
Yeah, nice reference. Yeah, all right. Thank you for that. So that was a quick upcoming events by Red Hat. So thanks for joining our talks. To wrap things up, we just have a quick feedback form. If you don't mind filling this one out, it will just take 2 minutes, and we've got some swag. Sorry.
That's right.
At the end, so depending on, I think we've got,
Oh, yeah, everybody, you
Yeah.
can grab a beanie on your way out.
yeah, so these
So
ones
there's the Red
are
Hat one, yeah, definitely. And
special
then,
ones, yeah, from just like custom Kubernetes logo, and then this one from CSF. We actually got this from the KubeCon at Amsterdam in April. So some t-shirts of various sizes. So if you don't mind filling this one quickly out, and we'll have a random spinner for that. And at the end, if you like to we have sort of just like a tradition by now, just a quick group photo to wrap things up, and then you're free to go. As Alfred said, you can grab a beanie on the way out. So yeah.
Yeah. Let's
Yeah, if anyone would like to stay, I'm not sure how long we've had this venue for.
oh, sorry.
Just, I guess if anyone still had any more like announcement they want to make, otherwise it's, yeah, the end of our formal meetup. So this was the form.